want to talk about today about the three common pitfalls in microservice integration, and basically also a bit about how to avoid that. Just a quick poll to see who's here. Who is doing microservices already? In production? More than one service? Okay, cool. Who's doing serverless, like function as a service, lambdas, or these kind of things? Couple of people. Who's doing at least like one, let's say, REST or SOAP call somewhere in the architecture? Yes. Okay, awesome. So that's actually what we see everywhere in the industry at the moment. So what we're currently doing is we're really moving towards distributed systems in quite a speed. So quite a while ago, we could do like Java programs on its own, and that's basically why I like this metaphor. So in that metaphor, basically, we have that small hut over there. And the small hut, that's your one Java program. And there it's relatively cozy to be there. You can program and you have ACID transactions. You probably know what your threads are doing. And you're kind of having control what you're doing there. But whenever you open the door, then you face that rough network over there. And the rough ocean, that's the network. And that will really do weird things. It will turn bits around and probably your messages will not arrive. Your REST calls will do strange things, and you will start to have that now everywhere in the architecture. And that poses a lot of problems on developers, which, at least to my experience, most of them are not yet aware of. Probably here at the conferences is a bit better, but if you go into the companies, that's quite of a big problem. And I wrote an article earlier this year on InfoWorld, so you probably want to look it up afterwards. So it basically also is about what I'm going to talk about today. I named it the same way. So it's the three common pitfalls. And basically, these are the three pitfalls I want to talk about today. So it's about remote communication first. That's a challenge we face a lot. It's probably, then you might turn it to asynchronous. Then you get probably other challenges. And my personal favorite topic actually is about consistency in distributed systems, and also known as distributed transactions. And I want to go over that today a bit. And as probably every talk, it has its opinionation. I just wanted to make sure you know mine. So who am I? My name is Bernd Rücker. I'm co-founder of Camunda. We're an open source workflow engine vendor, basically. But I contributed to a couple of open source workflow engines over the past 10 to 15 years. And I'm also, in my role, I'm currently still traveling a lot to customers, seeing a lot of different products. And that I'm always looking at the problems they have with basically the perspective of state machines, of workflow engines in the back of my mind. And what I experience is that a lot of challenges we see nowadays with remote communication require state handling to be solved very well. And that's also what I dive into today a bit. Okay, so that's just for you. For the back of your mind, probably good to know. We will run short in time at the very end. So if you have any questions, there's my email address, there's my Twitter handle, just tweet me. We're having a booth down there. So if you have any questions, you can also approach me there for the rest of the day, or just shoot me an email. So one thing we see if we do microservices, or if you name them something else, I actually don't care. What I care about is normally what we see is that we have more and more functionality sliced down in smaller parts, probably microservices, probably some whatever, and they're connected remotely. And in these architectures, something, and that's really a mind shift, you saw probably a couple of talks here already talking about that. The mind shift is that we accept that some parts of these complex systems are always broken. So not the same parts, hopefully, but some part somewhere is normally broken, or the network towards it is broken. We cannot really avoid that. We cannot simply throw money at it and say, okay, this is highly available. It doesn't work. It will be broken at some point in time. And that's much easier to accept it, to say, okay, yeah, we know that some parts are broken, but we make sure that this failure is not cascading through the whole system and basically bringing everything down. That's about resilience. And that's a very important thing to have in mind when you're going towards microservices. And I want to make an example of this, a very easy example actually, because I'm an example guy. So let's assume somewhere in the company you do a payment service because you want to collect money, you want to retrieve payments for whatever you do. And payments are probably credit card payments. And normally you don't do credit card handling yourself. So you probably leverage some provider, probably somewhere in the cloud, in the internet, like Stripe or these kind of things. And they normally have a REST API. So you might end up with this. So you have the payment service calling a REST API from the credit card handling. And if we're doing that in Java, today I'm doing a Java and Spring Boot example of how to do that payment. Who's doing Spring Boot here in the room? Oh, that's a lot. OK. Do I have to ask who's doing Java? No, Devoxx is safe, right? OK, so let's do that. What I have here is my IDE, and that's the most asked question normally. Yes, it's Eclipse. Why? Where's the problem with that? No, I still use Eclipse. I have to confess that, but it doesn't matter. It will work anyway. So what I have a small Spring Boot class, so it's a REST controller because I want to provide a REST API. Then what I do is basically I provide a put method on that URL. I do a couple of nonsense data transformations for the examples. That doesn't matter that much. And then I do the real business logic. I charge the credit card. And if I'm using Spring Boot, it probably looks like this. I use a REST template in order to do my post. I use a URL, which I probably get from some kind of registry. And then I have the request prepared as a Java object. I get the response as a Java object. And then I unwrap something from it and return it back. That's more or less what I have here. Who has done something like this before? Comparable. Yeah, a lot of people, right. So that's very easy to do. So let's do that just for the sake of the argument. So what I have here is I called it Stripe fake. So that's basically the credit card provider, which we don't look at the moment, but I need to be able to call something. Then I have the payment service itself. So that's my Spring Boot service. So that's the one I just showed you, just started up. And I have my postman. So what I can do, let's make that a bit smaller. I can call the method v1. I do that. What you can see over there, it charges a credit card. It goes to the payment. That charges a credit card. That works. I get back at 200 OK. It's relatively fast. So that's fine, right? So this is how it should be. So I could shut down the Stripe fake server. But that's kind of let's say, relatively boring because everybody recognizes what happens. Obviously, if I shut it down, I get a 500 here because this one cannot reach the Stripe fake. I get an exception. That's a 500. OK, that's easy to get. But another question, if I have a slow network connection to that service, and I can I know make the service itself behaving slow. That's easier for me. So this one is now slow. I call the payment, and this one calls the slow Stripe fake service. What happens? Kind of a test question if somebody is listening. I hear a couple of things. Yeah, I think I heard it. It's slow. Yeah, that's kind of surprising, right? So what it does, it calls the payment service. The payment service, like synchronously in a blocking way, calls the upstream or downstream Stripe fake server here. That takes a random delay, 56 seconds, and that means that takes 56 seconds, and it's now blocking here for 56 seconds. Why is that bad, actually? That's really exactly this slide. So what happened is I had the credit card service, the Stripe fake here, behaving slow, or probably the network behaving slow. That's kind of thing we probably should accept. But now we're having the payment service. The payment service has a thread pool, and that thread pool now is normally blocking for the upstream credit card request. All the threads are blocked, waiting for responses. And that means at some point in time, I cannot do any more payment requests. And that basically cascades the failure because I have, for example, whatever an order fulfillment service now cannot calling the payment service anymore. And that cascades exactly that failure. So that's a pretty bad behavior to do. So slow services are really bad. What could I do about that? That's normally also a very known pattern. Could I hear that somewhere? Timeout, yeah, I hear timeout. Timeout is the right thing, actually. Who has heard of a pattern called circuit breaker? OK, most of the people. That's pretty good, actually. That's pretty good. That's important to know. So I don't want to talk too much about circuit breaking. But what I can do is I can use a circuit breaker in the Java world, probably Hystrix. There are others as well. But in order to make code examples, I have to use one framework. I use Hystrix from Netflix. And that's my V2. And actually, the code doesn't change much. So the church credit card, I still have my REST post thingy, so that didn't change. But I nested it in a hystrix command. I know in Spring Boot you could just say add hystrix and these kind of things, but I wanted to have it like this because then it's very easy to understand what happens. I just nested in the hystrix command, and then hystrix is a circuit breaker, and that works like circuit breaking in your house. So there's something wrong or weird with the electricity. Before the house burns down, it just switches off electricity. And that's the same thing hystrix does here. So if I call v2, I send it over, it goes here, it goes there, it takes 16 seconds. That's too long, so I get a timeout in the circuit breaker. What you can see on the right-hand side, you get an exception from hystrix, and you get back a 500. So that's much better than cascading the failure. If there's something weird, just switch it off. And hystrix is really clever, so you can it retests if the connection comes back and probably even automatically switch on again. Okay, so that's an important basic pattern. I'm really happy that most of the people raised their hands that they know it. So that's a circuit breaker. Circuit breaking is also, and if you're in like Kubernetes world, then this is very often also known as the service meshes. They are also doing circuit breaking, and that's known as fail fast. Because you don't want to wait until you're really keeping the thread hostile. No, you want to fail as fast as possible. But what I experience in most of the projects is that they stop there. So they say, okay, fail fast, we're doing circuit breaking, awesome, we're done. And that's, I think, not enough. And I want to tell you a short story in order to visualize that, which happened to me personally. Who has used an airplane before? Okay, most of the people. So that's good because you're familiar with the process, right? You book a ticket, and then 24 hours before your flight, you get an email invitation, hey, please check in. Then you click on the link, you select the seat, you confirm the check-in. And then when you're checked in, there's a button like send me the boarding pass, like via email normally or via text or something like that. And I did that for a flight to London like last year. It was a German, from Germany, so it's a German website, so for that, but it was Eurowings. And I did that. I was checked in, and then I clicked on the button, and it basically said, there was an error sending you your boarding pass. That's a bad thing, right? I need that at the airport. We don't have Eurowings as a customer, but we have customers which do comparable things. So I envision it like this. It was me in front of the web UI. Then there was probably a web UI. The web UI communicated with a microservice, probably a check-in service. And the check-in service doesn't do anything on its own. It uses other downstream services, like, for example, something to generate these 3D barcodes or for generating the PDF. If you're flying British Airways, they still provide you with the option of sending you a fax, which I totally love. I always want to press that, but I never did that. Then you probably have like more microservices there, right? And what I think that happened is that probably the barcode generation was broken. Okay, so you couldn't generate the barcode. And early on I said that's kind of acceptable. There will be times, like always, when something goes wrong. So that's kind of okay. But and they somehow like really had, I'm not sure if it was a circuit breaker or some other means, but they really made sure the overall system was still like responsive. So because I couldn't do the check-in, I could do the check-in, which is not always the case. I'm flying too much at the moment. So I had a check-in at United in New York, and they gave me that error. So really the whole site was unresponsive there. So that's really the worst thing you can do. So I think these kind of circuit breaking components are really the minimum. But it doesn't stop there, because what you do basically, you transport that error you have somewhere downstream, really to me as the user. And that's a bad behavior, because what can I do about that? It's normally for programmers, it's very obvious. Have you tried turning it off and on again? I mean, hit F5, of course. That's what I did. I retried it like immediately. It didn't work. I got the same error. So I basically retried it like a couple of minutes later. It still didn't work. So what I did next is actually, I wanted to retry it like a couple of hours later, right? But in order to do that, I created a calendar entry in my Outlook, not to forget it, like a couple of hours later. That's what I call a stateful retry. It's stateful, it's persistent in my calendar, so I'm pretty sure I remember it, even if I, drink beer in the meanwhile. And and then I have to come back to retry it. And I think it's a really bad design here that I, as a user, have to do that. The fun part of that story was actually on my onwards flight from London. It was the same trip. I flew EasyJet, and I had the same problem. But that's actually awesome. They give me the work instruction. So they say, we're having some technical difficulties. OK, I recognize that. Please log on again, so retry. If that doesn't work, please try again in 5 minutes. OK, increase the interval. And the best part of that is we do actively monitor our site. We'll be working to resolve the issue. There's no need to call. It's your problem. Resolve it yourself. We don't care about that. And now it's really very obvious to see what's wrong here because it's customer facing. But this kind of attitude you see a lot when you have service-to-service communication within the company. If you have another service which consumes what you provide, that's a client. And you shouldn't have this behavior towards him. It should be much more like, oh, we are having technical difficulties. That's actually bad. We are having them. But we will make sure to resolve that just in time. I mean, in this case, it's a boarding pass. I don't need it like synchronously in my browser. I want to have it on time when I go to the airport. They send it normally via email anyway. They can send that in 4 hours. They can do that stateful retry itself. So it should be actually done in the component who is really responsible for that. And this example, I would argue that's the check-in service. It's not me, definitely not me. It's the check-in service who should do that. As soon as you think about that and you want to do that, and if you talk to teams having this kind of problem, normally they're kind of aware that they should do that. But then it's like, oh yeah, but it's stateful. I mean, there's something like Spring Retry, for example. They can retry like immediately. But that's for network hiccups. That's okay. But if you're for this kind of problem, that doesn't help because you have to retry for a longer time. And then people are saying, yeah, we know, but then we have to handle state. And handling state, I mean, it's 2018, shouldn't be that hard. We have a couple of mechanisms to handle state. I always call this persistent thing. It could be like an entity, a database table. It could be a persistent document store, NoSQL. It could be persistent actor if you fancy it. There are a lot of ways to persist this kind of state. The problem is as soon as you do that, you start to have additional requirements like the retrying that needs to be scheduled. You probably want to have some operation. How many boarding passes are currently in retry? If you change the procedure, how you send out boarding passes, you probably still have ongoing things, and you have to think about what to do with them. So you have kind of a versioning problem of the new version and the old version of the procedure. So there's quite some complexity involved. That's why, at least to my experience, people are really backing off that idea. And then it's state handling. So there are state machines out there. Nowadays, there's normally workflow engines, called workflow engines also. And then if I propose these kind of things, normally people say, yeah, but a workflow engine, these are these huge BPMS systems from the big vendors. They are really, really bad, really proprietary, really heavyweight. And we have to, what I call death by properties panel, I have to click through a lot of wizards in order to get going. That's not what I want to have. And that's not true anymore. I want to make an example in a minute. And it's especially interesting to look at that workflow engine market at the moment. So if you look at what's happening there, if you look, for example, at the cloud providers, all of them start to have some kind of workflow engine state machines there, especially also for these kind of problems. So in AWS, it's, for example, step functions. But Azure and Google Cloud also have things like that. If you look at the Silicon Valley stacks, what these companies are doing, they all develop their homegrown stuff like workflow engines there, like Netflix did, for example, Conductor, or Uber did Cadence, or Airbnb did Apache Airflow. So there are a couple of really tools emerging there. They're normally very opinionated for the environment these companies work on, obviously. So Uber, for example, they do it in Go and persist on Cassandra. So that's the only environment you can run it on. So that's normally really nailed to what you have. But it shows clearly that they have this kind of problem. And there, especially in the Java space, there are quite a lot of open source engines out there. Like the one we do, that's Camunda, or fork of Activity, or you probably also heard of JBPM and others. So there are quite some options. They're pretty lightweight. I'll show what I mean by lightweight in a minute. Also at scale. So I don't go into any details of that. But if you're wondering, like, because I propose this, for example, for retrying when you do REST calls. And we have customers doing whatever 100K REST calls per second. Does that work on a workflow engine? And there are ways of getting that to work, but I'm not talking about that today. But it's not a showstopper anymore, technology-wise. But for today, I want to use, by coincidence, the one from us. But it's open source, and it's really comparable to the other options there. So it's for me, the important thing is like how you can envision that. And I'm a code guy. I always want to make examples in code, so I have to use something. And if I move forward with V3 here, so the next thing I do, I want to have that retrying like for a longer time, long-running retries. Again, I have my REST controller. What changes is I now use the workflow engine here. In this case, like for Camunda and some others, you have a Spring Boot starter. So in my case, I just add the Maven dependency for the Spring Boot starter, and it's just there. It persists in a relational database. It uses a data source from Spring here. Then I can define my workflow, and I could do that graphically, but I prefer to start with code, because normally what I saw for a lot of developers, they're kind of afraid if they see graphical models. There might be magic behind it, something hidden. So I start with code normally. I say, create an executable process, start it. Like this is where it starts. Then the only thing I basically do is calling a service. It's called a service task. I attach code to it. Because I'm in Spring, I can use a Spring Bean. So the stripe adapter is defined a couple of lines down. So that's my stripe adapter. It's just a Spring Bean. And I simply move the code I already had into it. So this code hasn't changed. That's a code from V2 with histories and so on and so forth. I just moved it to that class in order to be able to attach this to the workflow. Then I'm basically done. And now I have a state machine. I could do things like, if that fails, I want to have a retry. In this case, I did it very easily, like retry 3 times with a delay of period time 1 minute. This is how you can read it. As you can see, that's very easy. And then I deploy the workflow. Now it's also versioned. A lot of these kind of versioning problems are solved by that. And now if I charge my credit card, I'm not actively directly doing it and block the call. No, I'm just starting the workflow. I probably hand over all the data to the workflow, which I need in order to do it. And then I'm basically done. So that's the only changes. By the way, all the code is on GitHub. So if you want to read it back or play around with it, it's on GitHub. So don't worry about that. So now the behavior changes. So I go back to my Postman. I go to V3. My Stripe service is still slow. So it's still behaving slow. So I should still see an exception from histories. So I do that. You see the exception. You see it's still slow, but the behavior changes here. So one thing you probably notice, and that's interesting, I switched the response code from before that, when everything was right, it was 200. Now it's 202 accepted. 202 means I got your request. I will do it at some point in time and talk to you back. I call you back, right? So I'm basically switching to asynchronism here. I come back to that in a second, okay? But so here I don't have a 500 anymore. And what happens in the background, if I talk long enough, we see another exception passing by because the retries are going on. And normally these kind of tools, they have some kind of console that depends a bit on what you use exactly. For us, we're having so-called cockpit. Let's quickly look into that. And then you can basically see, okay, there are certain things going on. For example, for that V3, there's currently like 1 instance waiting. So what you also see is we generate these graphical models out of the code, but we can see there's something waiting, still doing the retry. So it's persistent, it's retried even for a long time. Normally, if I do this, if I propose this, then the next question that comes up is like, okay, but 202 accepted. Now you switch it to asynchronous. We don't want to have that. I mean, we want to have a synchronous response. I discussed that, I think, hundreds of times for kind of if you imagine booking processes, like you want to book a train ticket, then you select everything, do the credit card data, and at the very end you click book. And then also business folks are normally really thinking, okay, now the next thing that has to happen, I need the PDF, like with a ticket, in order to print it out. And I discuss that really often because I don't think so. If the decision is I get either asynchronously later on my ticket, like via email, or a synchronous error message, I definitely know what I want to take, right? So I think switching to asynchronous should be in the toolbox. But what I can do, and that's actually, I don't walk you through all the code, so that's homework. But it's easy to do, actually. A couple of lines more. Then what I can do is v4, it's still 202 accepted, but my Stripe fake service is slow. If I switch that back to normal, then also this is switching back to 200 OK. So you can do it, you can use it in a way where you say, if everything is fine in my whole system, then you get a synchronous response. That's fine. But it's kind of it's a happy path. It's a happy case. If not, then I'm switched back to asynchronicity, like with 202. Okay? That's, from my perspective, a very important pattern. Or you immediately switch to asynchronicity. That's also fine with me. Okay. So what I did do, basically, and now I have my payment service. I have Hystrix used in there in order to safeguard the REST API. And I used a very simple workflow in order to do the stateful retry. And it's really stateful. It's persistent. You can switch it off and on, and it will keep retrying. So if you promise we send you your boarding pass later, you can now really do it. OK. So that's the client doing the retries. That's actually, even if you don't do it stateful, retrying will be part of every distributed system. You cannot really get around retrying. If you do retrying, I want to also talk briefly about idempotency. So if you do retrying, obviously you probably get a call multiple times as a service provider. You have to be able to handle that. That's so important. If you only want to take away one thing from the talk, it's probably that idempotency is really important. If you do a service, make sure the API supports idempotency, because you normally can decide how to design the API and if it's idempotent or not. And again, I like to make customer-facing examples. Do you remember the pages? They're almost gone. Not completely. I see them from time to time, but almost gone. When you pay something with credit card, you enter all the data, you hit pay, and then you get this loading screen where it says, don't leave the page, don't close the browser. It always makes me like, I want to close the browser. What happens? But it's my money, so I don't do it. But then I'm still normally doing these kind of things in the train. I'm really booking a lot of things in the train, and that's normally like, I'm in the train Wi-Fi, I see a tunnel emerge, and it's like, for God's sake, do it faster. Because that lets me feel nervous. That's bad. That's a bad design. And the same thing goes for service-to-service communication. I mean, you should do it like, in this case, you want to give us money, that's awesome. We make sure it's a really convenient experience for you. We generate some correlation ID, we store it in the local storage of your browser, or however you want to do it, I don't care, but do it in a way that I can come back later on. That's so important. That's my favorite slide, actually. There was a vegan time in my life, like 5 years back or something like that. Before I had kids, then you can do this kind of things. I ate vegan for 5 months or something like that. And there's a good vegan cookbook. And there's one dish which I totally recommend, which I loved during that time, which is kind of a pasta, but made out of the zucchini. There's a special slicer where you can like put the zucchini through, and then you get noodles out of the zucchini. You add some sauce, and it's totally tasty. Totally recommend that. In the book, they even write something like, you can eat as much as you want to, because that's very often with vegan and probably lose weight. That's an important thing. You can even eat it in the evening and as much as you want. Okay. So if you already ate a plate of zucchini, you can just eat another one. That's no problem. And another one. So eating zucchini is totally idempotent. Eating pasta is not, right? And that's important to keep in mind. I made this up at some point in time. I don't know any better metaphor. If you know, I'm totally happy to take it. But so far it worked pretty well that people are really remembering that. So remember the zucchini for idempotency is really, really important. But we are not done. We are still having a couple of problems to solve. So let's assume we do that charging of the credit card, probably even with a retrying. At some point in time, normally you give up So here I'm basically giving up. It might be that it takes too long, or you probably retry it for whatever 20 times, and you say, okay, at some point in time I just give up, and I basically raise something like a payment failed event, and then probably I cannot fulfill the order or whatever I do there, right? That's a normal thing to do actually. And the thing is, because we are in that distributed systems, there's one characteristic which is really bad about distributed systems. So we cannot, if we do a REST call and we get an exception, we cannot differentiate between 3 error scenarios. So the first is you're a client calling the service provider, and probably the network towards the service provider was broken and you never reached the service provider. You probably reached him, it did something for you, and then it exploded, and you have no idea if it committed its transaction or not. Or it did everything fine, it committed everything, so totally fine, but the response got lost. The network had a problem there. And you have the same thing if you do messaging, if you do asynchronous communication. You send a message out, you never receive a response. You have no idea what happened. And that's really a problem, actually. You have to think about this kind of problem. So in this scenario, the worst case, if I'm not idempotent, and if I don't care about that, I probably retried like 10 times, probably charged the credit card like 5 times, and then I raise you don't get your order because you didn't pay. That's quite a bad design. So I have to think about it. The strategy to resolve that is probably different depending on the API you have. So probably the credit card service provides something like a cancellation API, or probably you try to issue a refund, or probably you ask the credit card service if he did that charging, or whatever it is. There are a couple of things you could do. But the important thing, again, is it might be stateful because, I mean, if the charging of the credit card is not reliable, the service is not reliable at that point in time, it's very likely that you have the same problems when you call it to cancel it. Right, so it has to be reliable again, and probably doing retries and these kind of things. Okay, what I used here is BPMN. I'm a huge fan of BPMN. That's the language I used in order to define these kind of workflows. There's a book available. I also wrote that book quite a while back. We have some of it at the booth, by the way, if you're interested. But I'm not a fan because I wrote the book, and now I have to be a fan. I'm still a huge fan of BPMN because the language is very rich. It's directly executable. So what I showed you, the Java code, that generates a BPMN directly executable. So it's no generation, no kind of translation step necessary. So it's really there. And the language is really very, very powerful. I show you that in a minute. So even if you're probably not, for example, don't want to use Camunda, I would go for a language engine that supports BPMN as a language. I think that's very important. It's widespread, so even like worldwide. It's an ISO standard, so a lot of people know it. And it's easy to understand, and not only for developers. So if you look at, for example, Apache Airflow, they're defining flows in Python. That's for developers, that's kind of okay. But if you want to, for example, discuss it with business stakeholders, on the one hand, that's kind of a no-go. But also operations, I always think about operations. So in our example, and these, depending on the tool, that might look different, but you have things like, okay, there are currently 317 having a problem here. And even if your operations is not a developer, he can understand that, okay, that's there, this is how they got there, this is the data attached. So you can understand a lot of things also because of the visual. And you can even visualize like audit data, or what's a normal flow, where we very often have problems. How long does it take, and these kind of things. Even if you're talking about milliseconds sometimes. That's we make a lot of good experience with that. And if you compare that to other languages, like what I said, Python, or like step functions, they reinvent a language. I'm doing workflow engines for 15 years, and I already foresee a couple of the problems they will run into because they reinvented the language. We did that like 15 years ago, and we learned a couple of things which are now in BPMN. So that's probably a personal thing. So go back to technology. There are a couple of options to really do that. If you want to use a state machine like this, there are a couple of options. You can look it up later on if you want to. I blogged about that. So what I did here, I basically just ran the workflow engine as part of Spring Boot. And then if I have multiple microservices, that's important. I come back to that at the very end. If I have multiple microservices, they probably run their own engine. So it's really an implementation detail of one microservice. If you're not using Spring Boot, but Wildflower, WebSphere, or whatever, you can also do that there. That's relatively easy. If you're not running Java at all, you're probably connecting remotely. That's also very easy as well. Okay, so far we talked about synchronous communication, and a lot of people raised hands when I asked who did that in the past. So I guess a lot of people do REST. Who does REST in the architecture? Yeah, that's probably 2/3. Okay. I already talked about that. I doubt that you always need that synchronous response like in the requirements. And I pull up this slide when I discuss it. I love that quote, totally. It's from Todd Montgomery and Martin Thompson. They're really doing a lot for distributed systems. They're also speaking at a lot of conferences. I totally recommend their talks. And they said synchronous communication is the crystal meth of distributed programming. It's a bit like, we know that this might be even bad for our architecture, or we might get problems with that kind of thing. But, I mean, look at the Java code I did earlier on. It looks like a local method call. It's so easy to do. So just, we have a tight deadline, just do it the last time. Tomorrow we will do better. And that's kind of the problem there. So I personally think it definitely makes sense to look at asynchronous as well. And if you do that, we have, comparable challenges sometimes. So if we go back to the Checkins example, and we assume we're using messaging there, it might look like the check-in sends a message to the barcode generation, and it sends a message back, like the response. Now we have to handle basically that we don't get a response. We might not have like network exceptions while calling it, because normally the message bus is available. We can put a message there, but we probably never get a response. And so we have to handle that, and we don't want the user to be the one who's waiting for the message and tell us, hey, there was no response. So we probably want to do that. And then it's a lot about timeout handling. And again, this is exactly the scope of state machines. What they can do, for example, send a message out, wait for the response. And if that doesn't happen within a certain time frame, and that's now a detail of BPMN, that's a dashed line. So it means I keep waiting, but I do something additionally, like this is again retrying. I send another message because probably the request message was lost. But that's again stateful. I can wait even for a longer time. I can do probably even more sophisticated things, like independent of where I am in that process. If it's too late, I do plan B. Also happened to me already. Virgin Atlantic recently sent me an SMS like, oh, I'm sorry we gave up, we cannot check you in, please go to the counter. That's, by the way, the good thing about that talk. Since I give that talk, I'm really happy when I get flight, error messages during check-in, which is kind of a weird thing. But I collect them now. I have like 20 airlines, I think, already. So they're really, sometimes really bad at checking in. Okay, so we do the retrying, we probably do the timeout. The service provider still have to be idempotent. Who uses a message bus here in the room? Keep your hands up for a second. Who has no problems operating the message bus? Nobody. Nobody. Normally it's one guy. Always. I have no idea why. Probably he follows me. But the thing is, and that's surprising. I totally agree. It's safe to ask a no problem question. But what I see at customers is that if they have messaging, and I really think they should sometimes, then whenever you process a message, you get an exception. Then you have no client waiting. So what you do is you have that message, and it's called a dead message. It goes to the dead letter queue. Somebody has to monitor the dead letter queue, see, okay, there was an error, look into that, probably retry it. So somebody has to take care of that. And there is a lack of tooling supporting that. So most customers I know, they cannot easily do that. They cannot look into the message. They cannot look into the payload. They cannot fix the payload if the problem was in the data, and they cannot redeliver it. And that means they build a lot of what they often call message hospitals. And that's quite a lot of work. I see that really often around. And what I also experienced, and I never really was brave enough to say that's kind of an architecture blueprint, but I see that at a lot of customers. So far, instead of using something like a workflow engine in order to actively call a REST service, that's what we did so far. So that was our Spring Bean, actively calling the REST service. If you use messaging, it would mean the Spring Bean would probably push a message to AMQP, but that's kind of a push model. You can use these engine the other way around in kind of a pull model. So you could say something like the workflow engine is kind of a work distribution. Service task means it waits for somebody to say, I can do that. which is probably another service, and then it fetches the work, it does whatever it has to do, and then it tells the engine, oh, I'm done, you can move on. That's like a pull model. And in this, if you use that, you can probably in a subdomain of your company, but then you can do something like I had the workflow engine as kind of a work distribution. I deploy the model there, and then I have multiple services subscribing for different services, and that removes the need of having the bus, like really a message bus, but you're still asynchronous, and that's actually quite powerful. That's at least interesting, probably to have to have that in mind when you're thinking about these kind of problems. Has anybody heard of the thundering herd problem? A couple of people. Yeah, it's normally not that known. It's an interesting problem, actually, and that relates to that very much. Thundering herds basically means if you have a service and that has a problem, probably it goes down. And then you have the retrying I talked about. And if it's down for a while, normally a lot of retries pile up. And if you bring it up, it normally means that you do your own denial of service attack again, because you shoot all the retries at it. And especially if it just comes up, it's probably not that stable, and it crashes again. One of the most well-known examples of that is actually one outage of AWS. A whole region went down for 5 hours in 2015. It really, you had affected services like Netflix, Tinder, Airbnb, so a lot of important things, right? And I personally was affected with Trello as well. So that's quite a huge thing. They have postmortem online, so you can read it up, what happened. But it was basically a relatively small component that went down for whatever reason. And when they brought it up, all the retries basically hammered it down again. And it took them a long time to get it up safely again. So that's a thundering herd problem. You should definitely try to avoid that. That's one of the downside of retrying and REST calls. You get rid of that, depending on the architecture, probably by messaging, but definitely by pulling for work, because then you can decide for the rate where you're pulling the work. I love UK press. They did that headline out of that, which I really don't know why they put that headline and that picture together. That's kind of a weird decision, but that's UK, I mean. Love that. Okay, now 9 minutes left to talk about my favorite topic, distributed transactions, consistency in these kind of architectures. So the basic problem we want to talk about there is we want to do A and do B in an all or nothing semantic. That was easy when we had like Java code. We could use like probably Spring Transaction Manager. We say begin transaction, commit transaction. Easy. But it's hard in distributed systems. And it's hard to think about these asset capabilities of these kind of transactions. And I actually had a whole talk on that, or I'm still giving that, but there's one recording which I probably recommend if you want to dive deeper into, because here I just scratched the surface. I called it lost in transaction at Java Zone, for example. So you can look that up. The thing is that if you have that distributed system, you cannot do real asset transactions. Like, who knows of Twophase commit XA transaction? A lot of people who use that in production. No problems? Oh yeah, there we are. And that's quite normal. I mean, there's a really good resource. I totally recommend that. So I don't want to talk about too long why Twophase commit, it doesn't scale. It's too complex. It simply doesn't work in real-life scenarios. If you want to know more about that, there's an awesome article from Pat Helland. Pat Helland at that time was at Amazon. He's really one of the guys who thinks so much about distributed systems and write awesome papers. So I totally recommend reading that. And he describes very good why Twophase commit will not work in reality in relatively complex systems. And summing it up, using his own quote, it's like grown-ups don't use distributed transactions. So that's probably what you should keep in mind if you're doing a distributed systems. Don't count on like XA transactions; they will not be there. And a lot of like modern frameworks like Kafka or NoSQL database, they normally don't support XA anyway. So very often it's not an option. So what should we do? We still have that requirement of doing like two things in an all or nothing semantics. And one of the strategies, not the only, but one strategy is called compensation, or if you're in the microservice community, it's very often referred to as the saga pattern. And it basically goes like this. So I extended the example a bit. I say, okay, I still want to retrieve payment. Then I deduct something from the account of the customer. That's like a remote thing. So that's one microservice probably. So I cannot roll that back. I've done it. Then I say, okay, there's still some money left he has to pay. So I charge his credit card. This probably has a failure after some time, and I raise a payment failed. But what I cannot do, I cannot roll that back. But I deducted money from his account, and I raise a payment failed. So you probably want to have the money back. And this rewind symbol just triggers a compensation. And then in BPMN, I can basically define for this activity, if that has to be rolled back, I define a compensation activity, which basically is a semantical undo. So it's not a rollback. He probably sees that on his balance. It's not isolated as an asset, because in the meanwhile, where I'm still doing the retries, I deducted money without giving him anything. He cannot use that money for other things. So it's inconsistent in a way. But anyway, that's the way you normally solve these kind of problems. And you can directly execute that on workflow engines like caring about BPMN. And again, it's stateful. So even if you raise that and the customer credit service is not available at that time, you can do like the retrying, you can wait for it. So you can make it really reliable at that point in time. And I think that's quite a very powerful thing. And you can make much more complex examples there. So if you search for saga patterns, there are a couple of examples out there. Okay, let's quickly also do that. So if I go back to my Eclipse, we directly jump to V6. So if you want to look at the others, you can definitely do that. There I'm did a graphical modeling in this case, so I don't want to do that model in code. That gets quite complicated. But it's exactly like you saw it. And I can call V6. Let's do that. So we have payment, stripe fake, we call V6. And I get back at 202 accepted. So why is that? That's interesting. My stripe fake is still okay. So why is that? So if you look at that, what you can see is in V6, you're currently waiting for deducting the customer credit. And that's because I used that pull model I talked about earlier on. So if you look at the model, for example, here, it says something like called external task, and it has a topic name, customer credit. So I wait for somebody doing the work for customer credit. And this is just not running. Nobody is doing that. And therefore, I have to do a worker. In this case, I use JavaScript just for the fun of it. But it can be any language. It can be also Java. It can be C#, whatever you want to have it. And in this case, I just basically leverage the REST API of the engine and say, OK, I want to subscribe to the customer credit. I can do that. Then you get called back. You get streamed the work into the client. Then you do the business logic. And then you basically tell the workflow engine, I'm done. And then it moves on. And I have to start that worker in order to do it, actually. So if I start it, it processes the one instance, which we just had here. So if I do that, this one will be gone. So I will probably still see it in the history. OK, one thing stepped through. And again, like with a synchronous facade I have, what I can do is now, if everything is working fine, I'm getting him back at 200 OK. And depending on what my computer is doing, this is also fast. That's the second thing. Just because I know use these kind of things in the background doesn't make it slower. That's also what people normally think, but it's just not there. And if I do it a couple of times, you probably saw 500 passing by. So I do random errors in order to basically also show you that there are also errors, and then you can look into how the restore is doing. If you want to play around with that, that's probably homework, so you can really get a feeling for that. So this is how that works. Oh, sorry. So we have timeout retry compensation. In order to really leverage that, it means that the service provider has to provide undo methods. That's one of the biggest showstoppers normally. And if you do these kind of things, you're already really much prepared for this kind of challenges you have in distributed systems. So it's as if you provide a service, think about providing compensation methods and being idempotent, then you're really a good citizen in the microservice world. And a couple of these problems require state handling. It's just not doable without. If you're not doing REST or messaging, if you're really doing event based systems, you probably also want to look into that. I have the same example with payment extended for other microservices. Talking event-driven over Kafka there, discuss a lot about orchestration versus choreography, and you might want to look that up. And there you also see that just because you use something like a workflow engine, for example, in payment, doesn't mean that's a central thing. It's an implementation detail of that microservice, and probably order does its own like workflow because it probably orchestrates some parts. And if you have a requirement for state handling, it's probably good to embed that there. Okay, if you wonder if somebody's really doing that, for example, Zalando, they're doing order fulfillment, every order of our platform. They're doing that. They had a meetup in Berlin where they talked about it. And it's more or less exactly this, using Kafka underneath, using Camunda, using these kind of patterns. So it's kind of interesting. Probably, so beware of the complexity of distributed systems and know some strategies to handle it. I scratched the surface. So that's probably interesting to have a look at. Thank you for coming. We'll pull up the slides later on SlideShare, so everything is available. There are the links you're probably interested in. And yeah, I wish you a nice Devoxx. If you have any questions, either afterwards or down at the booth. Thank you.